Bom dia a todos, bem-vindos a mais essa nossa aula do curso de Introdução à Engenharia de Som. Hoje a gente vai receber a professora Louena Shtrepi. Ela, além de professora da área de acústica, é mamãe da Aurora, acabou de nascer, então a gente já primeiro agradece muito ela estar participando ter se disposto a dar essa aula, apesar de ainda estar no finzinho da licença maternidade dela. E a Louena, ela vai contar para vocês um pouquinho do caminho dela, mas ela atualmente é professora no Politecnico de Torino, na área de energia, mas atua em pesquisa na área de acústica, especificamente na área de psicoacústica e percepção. Então, sem mais delongas, Louena, thank you very much for accepting this invitation. We know how hard it is to go back to work after having a little kid, but I know it's also good to do something different than just stay with your daughter the whole time. So once again, thank you very much, and the floor is yours.
Okay, thank you, Bruno, and thank you all for the invitation. I was really glad to accept it. And as you said, it was great to turn back to work after quite a long time with a little baby. I think that this duty didn't end at all. And I'm waiting for the 18th birthday of Aurora to get free again.
80th, you want to say.
So, but it's quite nice to discover also this part of life. And today I will introduce a little bit of myself and how I got this interest in acoustics, and then go more into detail into some perceptual listening tests and how this kind of testing can help into a better design of acoustics. I chose a really, let's say, catchy title for this presentation, which is Deaf Architects and Blind Acousticians, which I will explain in a later slide. And I wanted to show that although we are designers, and although we are designers of acoustic designers, actually we most of the time we don't design through our ears. Although we actually use a lot of listening, and we are immersed in a world of sound. So maybe some more attention into this part can be also put into the architect's world. Why is this? Because let's say tradition for architects is to draw and to visualize things, but now we have to start also to give some tools to them for some oralizations. And I think this will be more important. Even more, the technology will go further and further on with the development. So just briefly, how I started my acoustic path. I might say that my life started in a small country in Europe, which is Albania. It is down here, and my passion for architecture started in this small city where you could see that there are some nicely made homes, and this is the city of 1,000 windows. It's named, and it's amazing how all this urban, let's say, old urban area here works also from the energetic and acoustics point of view. And then I went in Turin to start an architecture degree. And in my second year of architecture, I met an amazing woman and acoustician who is Arianna Stolfi, who became my mentor in the first undergraduate thesis, and then in my graduate thesis, master's thesis later on. From there, I had the opportunity to go in Aachen and to have a short period of let's say, full immersion into acoustics, where I met another amazing woman that you met, an acoustician, Monika Richtarikova, who became also another mentor and reference in my acoustics life, let's say. And I went back to Turin, and then I became an assistant professor there, finished my PhD, and now I'm researching and teaching in this university. I teach mainly, let's say, in an architecture faculty to designers and architects, but also to engineers. In Turin, we have this engineering degree, which is very specific, which is cinema and communication engineers. And there we have this a specific course who is named Engenharia del Suono, which is sound engineering. And the particular part of this course is that it actually collects let's say a broad contribution from different actors and different researchers and practitioners, and gives a very broad overview of what acoustics means in terms of design and in terms of specific let's say problematics and issues that should be solved in the audio and also acoustic world. I mentioned before that I teach mainly to architects and designers, which is actually not a very easy task for those who know the difficulty to teach acoustics. So you have to do some kind of tuning when you pass from the engineering courses to the architects and designers courses. So that this tuning has to be, let's say, explained in terms of tools and language that these different groups can understand and can really apply later on. I will start with these three inspiring books that have been also a guide in my acoustic path, which is Deaf Architects and Blind Acousticians. And actually, I invite you to listen to the environments where you are at the moment, but also later on when you will have the possibility to go out and to go to cafes and so on. And you will ask yourself if actually the architect who designed those places was deaf, or whether the merge between architects and acousticians in those cases worked well. And this is the aim of the work that I want to do with the people I teach to. The second book is the sound book, which is like the must-have book, I think. And it's very inspiring because it actually describes the sonic world where we are merged in. And it describes it from different specific phenomena that will actually catch you and lead you to new perspectives of what can be sound, which is not just communication, but is something also that is a communication of our world to ourselves. And the third book is Our Sonic Environment and the Soundscape, the Tuning of the World, which I have patiently read, and is something that I would recommend, highly recommend, and gives also, it's an old book, I would say, but in, let's say, in the last 10 years, where we have put a lot of attention into the soundscape of our world, and specifically in this period to our cities and the common spaces, it's something that I think you should read too. It are three books that change your perspective of sound and this world that contains that sound. So my question to you is: do you know how to listen? And how can you learn to become a better listener in a sonic planet? I think there is practice that is needed for all of us to become good listeners and experienced listeners. So as for sight, that you can see things that you are aware of. Also for the listening, I think that you could listen, not hear, but you could listen only to things that you are aware of. So start training yourself and to listen in a better way. It's not a very easy task, but I think with some methodologies you can make it. And I think also in the practical aspect of your work as acoustic designers or architect designers or engineers, let's say, you should do this. Acoustics is not something that only gives, let's say, negative sounds that should be controlled, but you can also highlight the good part of those sounds. My research question from a long time now is when less is more. This less is more is a phrase that I have borrowed from a great architect, that is Mies van der Rohe, and by chance he is also from Aachen. He was born there, and this question helped me to understand a little bit better these surfaces that you see here, which are sound diffusers. This is an example from Elbphilharmonie. My question is whether this kind of surfaces are hearable, are audible by our ears compared to, let's say, reflective surfaces. So what could change if all these concert halls were only flat surfaces? Sometimes architects love to have flat concrete walls, but sometimes this is a little bit too less. And as architects and designers, we are asked to renew the aesthetical aspects, but as acousticians, we are also asked to maximize the acoustic properties. And both these two categories have to be creative in order to make not only, let's say, correct designs, but also creative designs that can improve and bring to well-being of people in different environments. Just briefly, you might have already seen different acoustical treatments properties, which is mainly absorption, reflection, and diffusion. And as you could see, with absorption, we have like a loss of energy. You could see it in this graph here. And through the special response of this kind of surfaces, you see that there is very little energy that goes into a specular reflected direction compared to the arrival part of the sound, which is the arrow that I am signing here. With the reflective walls, like as I said before, concrete walls, for example, you see that there is very little loss of energy, and you have a lot of energy that goes in the direction which is specular to the arrival one. And with diffusion, which is the surfaces that I was showing before, you see that actually you have some distribution, distribution of the energy in time, and you have little loss of energy. So if you see what happens especially, you see some differences between these two conditions, and I want to understand whether we are able to hear these differences or not. And when it comes to do this, so to answer to these kind of questions, you have to deal with listening tests. And when you deal with listening tests, you have a list of things that you should do in order to arrange a good listening test. And for example, to have a research question that is approved by an ethics committee, which is not that trivial, because you have to deal with subjects who are people that have to hear certain messages, certain signals, and you have to understand whether this is possible or not. For example, you cannot make them hear very loud sounds, let's say, or put them in a condition that brings, let's say, negative feelings and so on. This has to be approved by an ethical committee. You have to choose a test paradigm, which means how will be compared the conditions that you are testing. So maybe you can choose a paired comparison. You are comparing two different conditions. Forced choice, which means that you have to oblige people to answer to your question. Or evaluation scales. They can answer in scales, in 5-point scale, in 7-point scale, or with preferences, let's say. You have to choose the stimuli, which is the length of the stimuli, which is the frequency content. Does this frequency content actually excites the tests and the question that you are, the research question you are answering to? as well as you have to choose the subjects, so how many people you need to answer to that question, because this is something statistical that you have to deal with. Should these listeners be experts? Are they untrained listeners, for example? Which is the age that is acceptable? Which are the hearing characteristics? Not all of us have a normal hearing condition. Which is the test duration also is very important. So are you going to do a 1 hour test, 2 hour test? This is not possible because of the concentration loss that you will get in those 2 hours. So it's preferable something very, very short. Where you will perform the test. So is there a specific room? It's an ambisonic system you're using, headphones. And what is important in the test environment is that it should be as much as possible silent. So you have to have this background noise at very, very low levels. And how you will administer the test? Is there a user interface that you will have to present to your listeners, or is it on paper, the answers you are collecting, and so on? For example, for soundscape testing, in situ testing, it might be preferable something on paper, but in laboratory, maybe something digital would give more, let's say, normal conditions for all your subjects and more controlled conditions. And which is the analysis that you are going to perform on your data? So which is the statistical test that better represents and analyzes your data? All this, if you are interested in more details, I think you could go and see this book as well. But this was actually interesting to introduce, since I will go on to a more specific case study, which was performed on diffusive surfaces that I showed before. And this case study is a specific room, which is in Unicamp in Paris, and is the ISPRO. This room is very specific. It was designed by Renzo Piano and Richard Rogers, and the acoustics were made by Peltz. It is specific because it has this panels on the walls that are variable, so you can rotate them in an automatic way. And in this way, you can have these 6 conditions, which can vary the reverberation time of this room from 0.4 seconds to 4 seconds. This means that you pass from, let's say, a classroom condition to an almost cathedral, almost. But this was very interesting, since this gave some freedom to choose different conditions and test, for example, this condition here, which is very diffusive, with the reflective condition that I showed before. So in this situation, in this case study, what I wanted to do was to answer to the question, how much freedom do the designers have regarding the choice of the diffusive surface location? So are listeners sensitive to the location of diffusive surfaces in a hall? The question is very simple. If I put the diffusive surfaces in front of the listener or behind him, will he be able to understand these differences and to perceive these differences? Therefore, there were these 3 conditions here that you see. So with the front part, the gray part is the diffusive part, and the green parts are absorptive. As you see here, the other conditions are recreated in a reflective condition. So we have the same locations of the diffusers, but in 2 different conditions of the entire room. So very absorptive and reflective, in order to see whether there are some differences with the condition of the diffuser at different locations. In this condition, we could measure with the dummy head in 2 positions, as you see in this plan of the room. So the diffusive surfaces are in the front, in the middle, and in the bottom, in the rear part of the room. for an easy comparison, we could, and for due to the length of the experiment itself, we could just test the first and the third condition. So a direct comparison between these two extreme conditions were made in the listening test. As I said, we had the possibility to measure in collaboration with ITA in Aachen, the room through dummy head in two different positions and with an array of microphones, monaural microphones for just the objective acoustic parameters, reverberation time, clarity, definition, and so on were defined by what we measured here. And the listening tests that we could perform, given our possibilities in the lab, were made by using headphones. So you will see that the reproduction of what we actually captured with this dummy head was reproduced to the listeners through headphones. There are, let's say, technical issues that should be considered in this case. So, for example, the HRTFs of this dummy head compared to the personal individual HRTFs that we had with our listeners, we couldn't correct this. The equalization of the headphones, so we had to take out let's say the effect of the headphone itself in order to make as much as possible the conditions similar to the listening condition of the listener in the room itself. So what we are doing here is reproducing a virtual condition of what actually could hear the listener and the subject inside the room if he could enter the room. There are different techniques that can be used to measure a room, but in our case, we had the possibility to use just the dummy head. You could use also sound-filled microphones, eigen mics, which actually capture the 3D audio conditions and can be used to reproduce them in a more, let's say, in a more surrounded or in a more complicated conditions that are the ambisonic or other virtual rooms like the cave and so on. So immersive conditions. The objective parameters in this case were also analyzed, and I will just briefly show them. So we had the three conditions in the reflective with the reflective walls and the absorptive walls. And we see that there are some very sensible and noticeable differences in reverberation time, for example, with the absorptive conditions and with the reflective conditions. I will not go and explain in detail these parameters, but what can be immediately perceived, for example, with the samples that I will show you is exactly the length of this of the impulse responses that were measured inside this room. So in this case, we have like almost 3 seconds of reverberation time compared to 1 second of reverberation time. And the listeners were asked to give, let's say, feedback on whether they could listen the differences between the front and rear condition, in the absorptive condition, and in the reflective condition. So first of all, how were the listeners chosen? We usually call them from a pool of students and researchers of the university. In this case, we did a short listening test, so we could gather just 26 listeners. From these 26 listeners, we lost 2 of them, and we had only 24 data to analyze. When I say we lost 2 of them is because we consider them as outliers, since, for example, the length of the test they made was longer than what we expected. So there was something wrong with the procedure. In this case, we did not repeat the listening test. And the second one didn't have a normal hearing condition. So before the test started, we tested all of them through an audiometric test. This is just for screening purpose. It's not a medical test. And we could have the audiometric, let's say, graphs for all of them, and could decide on whether to consider or not some specific listeners. In this case, we were lucky that only one could have been considered with hearing problems. But this is very important and will actually influence your data and the results of the listening test. Our listening environment is an anechoic room. We didn't have the ambisonic room at that time, so it was performed through user interface in a laptop and through headphones, as I said before. The choice of going to an anechoic room is not that specifically we needed an anechoic room, but this is the room that gave us a low background condition. For some listeners, for example, it was required to make, let's say, a short period inside the room before the test started, because actually you could really feel the difference between the outside and the inside world, and this could influence also the test. So people who were not aware of what conditions they were expecting inside the room, they had to do some kind of let's say walking inside the room, going out and in, and so to get used. And the choice of the samples and the stimuli that we used in this case was a pink noise, an orchestra, and a trumpet. Let's say that the pink noise is just for experimental purpose and because we had the control of the spectra of the signal, but it's not that in this kind of rooms you will hear pink noise. I want to make it, I will show what a pink noise is. So I think that all of you won't go in a concert hall to listen to this kind of signals. The second one was an orchestra, which is this one. And the third one is a trumpet. So these were the three signals that we chose. And as I said, on the pink noise, we had some control on the spectral conditions. On the orchestra, we had, let's say, a sum of different instruments. So we could go also at lower frequencies with the sound energy. And with the trumpet, we had a solo instrument who had much energy at the mid and high frequencies, mainly mid frequencies. So in this case, we wanted to see also with specific conditions and instrumental content of the samples how the listeners would react to these samples. And the procedure that we could test, at the end we had 24 pairs of conditions that we had to compare, given the three signals, the two source conditions, the two head conditions, so listening positions, and the four different combinations that we have in here. I must say that we tested only the absorptive and the absorptive conditions, so positioning the diffusive surfaces in the front and in the rear part, and the same for the reflective condition, so with the diffusive part in the front and in the rear part. I will also show these two conditions with the orchestra. So this is the diffusive part at the front in the absorptive condition. This is in the reflective condition. Maybe those in headphones could appreciate the length of the reverberation in this case. And also here we have the diffusive condition at the rear part. Whoop. Okay, for those who want to listen more into detail to this kind of samples, I invite you to download the samples from Zenodo. It's an open, let's say, source library, and I have already uploaded all the conditions. So if you want to test also your listening abilities, you can go and download these samples. Given this, we chose to test the different conditions through an ABX method. In this case, it was sufficient to have an ABX method, which is a condition where you listen to sample A, to sample B, and you have to answer on whether sample A is equal to sample X or B is equal to sample X. So you have two known samples that are different, and you have the X sample that you actually don't know whether it is equal to A or to B. So you have to test to answer in this condition. And it was a forced choice instruction, so you had to give an answer, and we didn't accept it an I don't know answer. Whether this is because the differences that could be perceived in these cases are very, very small, and so we wanted to put our listeners in a condition, let's say in a difficult condition, that they had to answer and they had to re-listen to the samples as many times as they wanted. So the procedure itself, it was necessary to go through the audiometric test. The listeners were instructed through verbal and written instructions, and I really recommend this because it's very important that they know what they expect in the user interface, what they expect in the listening test, and also some training before is necessary and is very useful. And also we made sure that they understood some of the terminology that we used. For example, what means coloration, what means spaciousness, what means clarity, reverberation, and so on. So the user interface was made in this way. I will translate it in English as well. So the listener had to listen to all the signals all the time, so once at a time. They had to listen to A, to B, and X as many times as they wanted, but they had to listen to all of them. They had to answer which one was similar to A or to B, whether X was similar to A and to B. And they had to say how strong was the difference, and we could say here in a scale from 0 to 10, and whether they could perceive some differences and what type of differences these were, if it was coloration, if it was loudness, spaciousness, clarity, and something else that they could write, and if they had some preferences on the samples A or B, and they had to choose one of this. Given the collection of all this data, we had to perform a statistical analysis, and for the ABX test, given in a forced choice condition, this becomes a bit easier. Since it's a binomial distribution, so you have the possibility A or the possibility B to answer to. You have to combine, let's say, the number of trials that you give to the listeners with the probability of correct answers of 50% in this case, because you have A and B, and a confidence level of 95%. Given this condition, we needed 15 correct answers out of 24 pairs of comparison in order to understand whether people could hear the difference or not. And this is really hard to communicate with all of you, because it would have been nice to understand whether your answer would have been yes, they could hear, or whether no, they could not hear the difference. And actually we were surprised, and as you could see here, all of their answers were below the threshold of statistical significance. So we can say that they could not hear the differences between a front position of the diffusers and the back position of the diffusers. But still, this is the statistics, who is not very democratic, and we are acousticians, and we go and see also what is happening down here. So what these listeners that could give some answers of differences and why they give those answers, we went into detail to understand whether they were based on some specific attributes that could be heard on the 3 samples that we saw before. And actually, they could hear some differences given the attributes of coloration first, reverberance, and less for loudness, spaciousness, and clarity, which was a little bit lower, let's say, as an attribute given by the listener. And this pie here actually is very simplified, because what can be done with this kind of testing is something like this. So as you could see here, we have the wheel of concert halls, and you have really different attributes, like this is inspired by the wheel of wine tasting. And actually, in this case, we could talk about tasting of sound. And in this case, we can go more into detail and understand whether there are specific attributes that are triggered and elicited by the use of diffusers in concert halls in this case, but they can be used also in classrooms and in outdoor environments, for example. So the conclusions of this kind of testing is that some listeners could hear and perceive the differences independently of the source and the head signal. We could not find something significant on this. They mainly are based on coloration, as I said, spaciousness, reverberance, and loudness. And they showed that there is, let's say, not an important role of the diffusers in the overall perception of the room, but we should say that the listeners that we chose in this study are not experts. So also in this case, you have to pay attention who you are asking to listen to your research question. And we tested only one hole geometry. So in this case, all the answers that we gave are on this specific condition, but let's say in a shoebox condition of a concert hall, and also with non-expert listeners. We expect that with expert listeners that might be something more detailed and something different perceived, since as I said before, you have to be trained to listen to specific sounds. Therefore, from an acoustic and architectural point of view, there can be less constraints from the design issues into the application of specific types of diffusers into a hall. And some future works, as I said, we can enlarge this and broaden this kind of experiment to geometries and different sizes, to trained listeners and different degrees of acoustic scattering. There are other studies that have given answers to the threshold of the listening of this kind of diffusers. And some future perspectives. So given these new technologies like CNC milling machines, 3D printers, industrial robots, we can actually get whatever surfaces we want. And from this perspective, what is a visionary exploration is that we can build our environment and tune them by our listening at the same time. So we will have these robots that will draw and will build our walls and shape our environment, and we will be able through our ears to say, like a sculpture with the vision, we'll be able to go and tune the specific parts with the diffusers or absorbers and so on. And thank you for your kind attention, and I expect a lot of questions, I hope.
Thanks, Louena. Really, really interesting. I do have some questions, but I will let's see if anybody else wants to start.
Oh, hello, good afternoon. I have a question, actually.
Please go ahead.
Okay, thank you, Dr. Louena, for your lecture. I apologize for not having a camera, but I'm actually too anxious to enter in another device, like my cell phone, to have a camera. But I must say I'm a fan of her work. I've read a few of her papers, and I've been studying the scattering coefficient measurement for a couple of years now. So I was really anxious to ask you the whole past week, actually, what are your thoughts on the future of the scattering coefficient, and what our next steps should be? But I don't know. Your last slide, it just popped another question to my head, which is about the biomimetic schemes that I've seen developed. There are walls that I don't know if you probably know about biomimetic schemes.
Yeah,
okay.
Yeah.
Have you ever seen an acoustic test on them? I've seen this wall that it would open or close depending on air humidity. It had these hygroscopic properties. So I was really thinking the different geometries and scattering and absorptions that we could get from these surfaces. So what are your thoughts about these biomimetic and hygroscopic walls, let's say?
Thank you. Those are very interesting questions. Yes, are two very interesting questions. And the first one, okay, that is my personal opinion, but I think there is still a lot of exploration that should be done regarding diffusive surface and specifically into scattering coefficient. Scattering coefficient was, let's say, invented to give some properties and objective properties to these surfaces. But as I said, and through this talk, I wanted to highlight that there is something that maybe we miss when we measure this kind of surfaces, because we focus on quantities and we don't focus on the listening. On my PhD, I focused on understanding, for example, the uncertainties of the measurement of the scattering. And actually, the uncertainties of the method of measuring the scattering are very high. But if you compare them to our ability to hear the differences between different degrees of scattering, that is very low. This actually, I hope, gives some answers, but I think we should move from a new perspective, which is the listening of this kind of surfaces, and also of listening of different degrees of scattering surfaces and explore new forms. And for example, I think the future work should be focused and will be focused, as I see from the tendency, on meta diffusers, which actually give some new, let's say, breathing to the diffusers, which are not only Schroeder diffusers, but give also the possibility of having, let's say, thinner diffusers, but with same properties as huge ones. Maybe diffusers that can be hidden behind other surfaces, because this kind, the diffusers of the state of the art, they become, let's say, part of the architecture and influence a lot our perception, visual perception of spaces. So maybe if we focus on listening and visual parts, we can get something new in the future.
Okay,
and,
so sorry.
Yeah.
So we're talking about some adaptiveness. We'll have some adaptive diffusers, but still the most important thing is if it will be perceived by the listeners.
Exactly.
So, okay.
So the question is, how much money do we want to invest on diffusers and not hear the difference at that point?
Okay, so
besides the part of the visual aspect, so if you like looking at the diffuser is something, And do you hear the difference between, for example, the reflective condition and the diffuser applied to wall? Maybe this is also dependent on the location. Let's say not only concert halls, but if you go, for example, in classrooms, smaller is the environment, more closer to the diffuser you will be, maybe more effects there will be, and these are all, let's say, factors that should be considered. But I think there is still a lot of research that can be done in this topic, but from a listening point of view.
Yeah, I think that maybe we focus so hard on design a surface that will have the best diffusion coefficient and higher scattering coefficient, but sometimes we will apply this surface on an environment that's not ideal. We have, I don't know, maybe its geometry is not ideal. It's we have high background noise level. So what's the point of investing so much money and time? It's kind of this idea also.
Yes, you touched a very good point, which is background noise. So that is the first thing to look at. And not only in concert halls, but also, for example, classrooms and let's say restaurants and so on. So after that, maybe you can deal with the absorption, scattering, reflections, and so on. But
thank you, Doctor.
Yeah, thank you. Nice question.
Thank you very much.
Now that we know that you have your first fan in Brazil, you might find
Yeah.
new ones. Or the groupies. Oh, that one too. Anybody else wants to join the discussion?
I'd like to ask something. Do you hear me?
Yeah.
Yes.
Yeah. Well, at first, thank you very much. Congrats. Awesome presentation, as usually. My question is about the spatialness, because it's nice that you said that people are not used to the anechoic room, but I saw before people having problems in asking for spatialness in a closed space, because we know that have this conflict in your brain, saying it's open or closed, or how your ears tell the space in your sight is saying something different. Do you expect bias or problems in this direction, I would say?
Yes, there can be biases. I think, yes, if you are not, it cannot be expected that what you are asking in a laboratory is the same, exactly the same, what you can experience as a listener in the room itself. Because we are, let's say, human, and we are made of different senses, and the visual part is part of the senses and can influence also the audible part. If there was a bias, I think it was a systematic bias for all our listeners. So at some point, this is something that is normalized in the test itself. But yes, I agree. There can be biases in the perceptual part, given the conditions of this procedure of test. So it would be nice to test the same research question with different procedures and to give a more solid answer to your question, I think.
Yeah. Once I don't remember who or when, but I saw a paper. They were trying to trick the person, offering the wrong audio for the space, and to test how people would realize that was the wrong. So in a different direction, they wanted to test how we perceive what, or the conflict in what we see and what we hear.
Okay.
Yeah.
Well, I didn't do that on purpose, but once I did like 20 people with the wrong test, and then I discovered it afterwards. So yes, I lost 20 subjects, but it can happen. I mean,
yeah.
They are all the same.
we have a question from Guilherme that I think it's very suited to the conversation that William introduced. Guilherme is asking, why didn't you position the listeners inside the room instead of recording and reproducing later through headphones?
Okay. Due to time issues, due to availability of the room itself, I mean the Unicamp room, due to the fact also that we don't have a very long acoustic memory. So if I put a listener in the, although it is a variable acoustic condition, and I could control it automatically, it took like 1 minute, 1.5 minutes to change all these periacs, which are the samples in the walls. And so it wasn't possible to immediately compare the conditions. So it was something, another bias that is the acoustic memory of humans, let's say, that didn't allow to do so. Yeah.
That's a really important question.
May I add something?
Sure.
Concerning this thing of memory, yeah, we kind of very short, and I was kind of reading something about, and when we mix spatial information, I read that our brain has a hard work to remember the combined information concerning the audio, let's say, and the spatial positions of the audio. So we were running some tests too, the virtual ones, and we got frustrating results because of the memory, I think.
Yes. And if I can say, the task that I was giving to the people, in this case to the subjects, was really hard. And as I said, I invite you to download the Zenodo database, but the differences are so small that actually, if you listen to that after 1.5 minutes, you won't remember the first clue that you listened to. Yes.
Eric, if you...
Hi, so thank you, Bruno. Thank you, Louena, for the lecture as well. I was wondering, like, I think, knowing your work, I think you have also conducted some research regarding the simulation parts, because you showed experiments in a room, so recording the binaural responses. And I think also maybe our audience and I myself have interest in knowing how this translates to a simulation where you are actually adding, artificially adding a scattering coefficient, or you are actually drawing the diffuser somehow, maybe not in complete detail. And also we have like this, the wave, the low frequency simulation and the geometrical acoustics. So I was wondering if you have any thoughts on that. And just to take this also to use the time of the question, I think Christian Santos asked on YouTube a similar question. So he said, "The great work, Louena. I would like to know what you think about create a virtual ambient to obtain the binaural response for a sound jury. It could be easy thinking about using a big room for this." So he was asking more or less the same question. So I was wondering your thoughts on that.
Similar. Yeah, actually, we have worked quite a lot also in this direction, and we have studied different, exactly this room, simulated with ray tracing methods and also wave-based methods. And what we wanted to test, for example, with the ray tracers, in this case, we used Audion. And in Audion, maybe some of your students and yourself have used this kind of software, and you need to put a scattering coefficient in order to launch the simulations. The scattering coefficient is something that let's say activates the model of diffusion inside this software. So what you need to do is to simply draw flat walls and assign the scattering coefficient, and it will take care about the directivity of the scattering and the diffusion inside the room, and specifically on the surface diffusive surface. So what we wanted to test is whether this kind of method gives you something more compared to, besides the time consumption of modeling the room, compared to the details introduced in the room itself. So we built a 3D model of the room with the periact, so this triangular pyramids drawn as 3D with no scattering, and compared with flat walls with the scattering assigned. And actually, we could notice from the same kind of test that people could hear more differences when you draw this kind of surfaces. And no differences, for example, could be perceived when the flat wall and the scattering was assigned to those flat walls. When I say no differences could be perceived, I'm speaking about a statistical difference. But as I said before, in acoustics, you have also to look at those 4 or 5 people who could hear those differences. From the perspective of the objective parameters, you might have correct answers. But at some point, so I would say if you have diffusers with a dimension of around 70 centimeters, let's say one of the dimensions, you have to, would be better to draw these diffusers, this kind of detail. We tested the same with a lower degree of diffusion, for example, and it was about 20 centimeters height of the triangular pyramids. And also this was in the same room. And in that case, you could not actually say the difference between the flat wall with the scattering and the built up, the 3D model of the room. So I think this is also very important if you deal with ray tracing models, because it's something that you should know in the settings how to deal with the model and the accuracy of that kind of simulation. But I think also in this case the future will be, as technology goes on, the wave-based models, because also in this case we tested the same room, and with a wave-based model the answers of the listener that we could get was very similar to what we had with the measured conditions. And also the similarity of the impulse responses were let's say compatible in the 2 cases. You could not say the difference at all. But also in this perspective, I think there is a lot to do regarding the scattering and how it can be considered as well.
Yes, thank you. Makes a lot of sense.
Great. Yeah. Probably didn't even notice, but we've been talking for 20 minutes about your work.
Great.
You expected lots of questions, and I guess you got them. We just reached 1 o'clock our time, which is our limit. I'm pretty sure people would love to keep talking with you, but time's ticking and we'll close by now. But before we go, I'd like to ask everybody to open the mics and give a big hand of applause for Louena for this great talk that you gave to us today.
Thank you to all. Thank you.
Louena, thank you very much. And I will just switch very briefly to Portuguese to give a warning to everybody. Pessoal, eu coloquei nos chats, hoje à tarde nós vamos ter o fórum permanente da Unicamp, com o tema do Ano Internacional do Som. Estão todos convidados, eu coloquei os links aí nos chats. Para quem ainda tiver mais um tempinho, eu apresento às 4h30 sobre a acústica das comunicações. Para quem não estiver lá hoje à tarde, a gente se vê semana que vem. Louena, thank you very much.
Thank you.
Louena, thank you, Bruno.
Thank you, grazie.
Have a nice day to all.
How they say in that movie, arrivederci.
Arrivederci.